that you are doing it right. Can you get the right answer without completing the square? Yes, but the directions said complete the square. So, when we complete the square, what we're trying to do now is put our parabola into vertex form, what we call vertex form. We're shooting for the form, something like this, where you can look at the problem and tell me the vertex, right? That's what we're shooting for. So, first thing we have to do is get ready to complete the square. This equation is not in shape to complete the square. So we'll subtract 6 and multiply by 2. Now, when you multiply by 2, you multiply everything by 2. And the purpose of multiplying by 2 is to get this coefficient right here to be a 1. If you're going to complete the square, that has to be a 1. You can't complete the square if there is a number here. All right, let me say that again. You can't complete the square if there's a number here. So whatever it is, you get rid of it. Okay. Now, everything is in perfect shape to complete the square. So half of 8 is 4. Squared is 16. So I'm going to add 16 to both sides. This is a perfect square. Right? What perfect square is that? X minus 4. X minus 4. And over here, I can add these two together and get 2y plus 4. Now, you've completed the square. So now it's just a matter of getting the equation so y is by itself. So you'll move the 4 back over. And then you'll divide everything by 2. Now, when you divide by 2, you divide the parentheses by 2, but not what's in it. So don't touch what's in the parentheses. So we have y equals 1/2 x minus 4 squared minus 2, which tells me that my vertex is where? Shifted 4 to the right and down 2. And your axis of symmetry then is x equals 4. Now, I'm going to keep taking points off if you don't write your axis as an equation. So if you want to keep losing points, just keep writing 4. It's got to be a line. X equals 4. Just like the asymptotes are lines. Your axis of symmetry is a line. All right? Anything else on the quiz you have a question about? All right, put that away. And what we're going to do now then is take a look in your packet. We're just going to start on the very first page. Just the front page of your packet, this old quiz that says period 5 is super. And have we done any of this yet? We did 5. Okay, so that, because that came out of 2-1, so we did that probably a long time ago. Now we are going to do the rest of it. Now you can actually do every other problem on this page. So here we go. Number 1. Find f of 2x. Okay, what does that mean? What does it mean when we say find f of 2x? What's that mean? I don't multiply by 2. That's not what it means. Oh, in terms of graphing, it means it would be half as wide. That's true. But what about in terms of evaluating the function? Yes, this isn't one of those that says, okay, here's the picture graphic. That's not what we're doing. We are actually evaluating f of 2x. So if I said evaluate f of 3, you would plug in 3. This says evaluate f of 2x, so I'm going to plug in 2x. Jade, why is your hand up?
I just had a question.
Those were in the last chapter. That subject, the big idea is not going away, but not a specific problem like that, no.
Okay.
You'll know what's on the test tape if you look at the review sheets.
Yeah.
That's what you need to do.
Okay.
Okay, right now though, we need to get busy, but we're not gonna have enough time, gotta get through this. So we're gonna plug in 2x for all of the x's. Now, when you evaluate this, please don't make me take points off because you messed this up. When you evaluate this, what do you do first? You square it first, PEMDAS, exponents. So we square this first, which gives us 4x squared times 3, so we have 12x squared minus 8x plus 5. Now we're going to stop right here. It's not equal to 0. You're not going to factor it. You're not going to do anything. What was your job? Your job was, what happens when we plug in 2x? When we plug in 2x, this is what happens. That's it. That's the answer. Now we have a sketch. Now we have done several of these, so this shouldn't be a challenge for you. What do you do first? You got to sketch this thing. So what you're going to plot the x-intercepts, right? Luckily, it's already factored. So you know you're going to have an x-intercept at -2, at 3, and at 1. So that part's easy. Easy. Now we need to figure out, okay, we have to connect these dots. We know they have to be connected, but we need to figure out how to start. So we're going to look at what? How many x's we have?
3.
Well, I actually have 5. Right? I have 5 x's. If you FOIL all that out, and I never want you to do that, but if you FOILed it all out, wouldn't you have x to the 5th?
Yeah.
Okay, that's odd. So that should tell me how I start then. I have an odd degree polynomial. How do those work? Start down and up. If you are still having trouble remembering that, think back to your BFF that's odd. X cubed. Where does x cubed start? Down, and where does it end? Up. That's what odds do. Think of your even, x squared. What does it do? Starts up and ends up. These are just, you already know these concepts. We're just magnifying it now. So it's x to the 5th, so we're going to start down here. All right? All these dots are connected with, lumpies here. Now, what happens when you hit -2? You've got 3 choices. You go right through, you bounce off, or you meander through.
You bounce.
You know you bounce because that factor came from, or that 0 came from this factor. It's squared. So we're going to bounce off. We don't know how far down we come, but we know we have to come back up and get this one. They have to be connected. Now, what happens here? That one bounces again because that factor came, or that 0 came from that factor. So it bounces off again, turns around. What does it do now? Straight through. Because that factor isn't squared or cubed or anything. It just goes straight through. Notice you started down and you're ending up, which is exactly what you should be doing when you have an x to the 5th. Brenton?
You meander when you have a cube.
Cube. Yep. Number 3, find the zeros. Now, this question could also say graph, because once you have the zeros, those are the x-intercepts, then you should be able to graph just about anything, right? So we are finding the zeros, finding the factors, and Jason has noted very wisely that this problem groups. Now when you have a big polynomial, x cubed, x 4th, x 5th, really, and you have to find the factors, you have 2 choices basically. You're either going to try to group it or you're going to start guessing numbers. The guessing numbers part always takes longer. It will always work, always. Grouping is shorter, but it doesn't always work. However, Jason has looked at this problem and said, whoa, 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 I got a 1 and a 5 and a 4 and a 20. That looks promising, doesn't it? So he says, I think it groups. And I think he's right. Now, Mrs. Ford's not saying you have to group anything. You don't. I'm suggesting you do if it's possible, because it's easier. But you can solve every one of these without grouping. When I group, I gotta have a common parentheses, and I do. It's x plus 5. And then what's left is x squared minus 4, which factors itself, right? X plus 2, x minus 2. So x equals negative 5, negative 2, or 2. And what were the directions? Find the zeros. There they are. If the directions had been graphed, you would do all of this and then plot these points, just like you did here, and then connect the dots. All right, number 4, same directions. Find all the zeros. What's different about this problem? Why did I put 2 problems on this quiz? This one doesn't group.
So here we guess number.
This one doesn't group. So we ought to guess some numbers. It's up to you, but anytime I have to guess, I think about, even if I don't write them down, I at least think about my PRRs, because the PRRs narrow down my options, right? So let's see, what would my PRRs be for this problem? I'm going to be guessing 1, 2, 3, and 6 over 1. So I'd probably guess 1, 2, and 3 anyway, so that's not super helpful, but here we go. Let's see if we can find one that works. Looks like 2 works. And when I say works, what do I mean? I plug it in and get 0. This 0 is the remainder. If you divided, some of you like to divide rather than plug in, you just like to do the synthetic division, and that's fine. If you divided by 2, which I'm going to have to do anyway, so I'll go ahead and do it, we're going to end up with a 0 right here, right? That 0 is the same as this 0. When I plug in 2, I want to know what the remainder is. I'm hoping it's 0. If this had equaled 7, then that would mean the remainder is 7, and it's not a factor. That's why I skip it and go on.
I thought it switched to negative 2 or minus.
No, it's going to be positive 2. It'll switch to negative 2 when you write it as a factor, like this. But no, the number you plug in is the same as the number you divide by, is the same as the number you plot on the graph. So if I were graphing this, I'd have something at 2. Those are all the same. The number you plug in, the number you divide by, the point on the graph. Okay, so I did my division, and I have this left. Now what is that?
X plus 3, X plus 1.
X plus 3, X plus 1.
So then your zeros are.
So my zeros, Hugh, be careful, don't forget. One of your zeros is the one you guessed.
Right.
And then the other 2 are negative 3 and negative 1.
Will you ever ask to like find the zeros and then
Oh yeah. Well,
How would you
actually, it would just say sketch, because in order to sketch it, you have to find the zeros first. So if you had to sketch this, all that would still happen. Now we have the dots we put on the axis, and then we know we've got a 3rd degree polynomial with no factors repeated, so it looks like that. Everything's just passing through.
how would you know what?
How would I know what?
Like if it didn't turn or.
Because none of these happen more than once. I have one factor for each one of these. Now, if I had divided by 2 and then I divided, and then I had something, and it came out like this, then that means, I have another factor of x minus 2. You see what I'm saying? But in this case, all 3 factors came out different, so that means they're all different. All right, and we did number 5 already, so turn the page. Have we done any on this side? Turn it, the back side down, on the back of that first front page. Which is a quiz that has a flower at the top.
Yeah, we did.
And we did number 5, the technical problem. So now we're ready to do the rest of them. We should be able to do all the rest of these problems. So here we go. Here we go. We should be able to do all of these problems. What?
Where did you get the x equals 2, x equals negative 3?
No, she was just saying.
The factors were x plus 3, x plus 1.
Oh, and then you just got the 2 because that's
the number I worked.
Okay.
That's the one I guessed.
Yeah.
Okay, now we're finding the remainder. Now, I know that some of you love to synthetically divide, and that's good. I like to synthetically divide too. But something about this problem has me a little bit twitchy. Okay, now, why does that bother me? Because when I do synthetic division, and I set up my coefficients like this right here, every power has to be represented. So I would have a 3, and then what would I have to have? A 0 for 49, a 0 for 48. Oh my gosh, right? So I don't want to divide. Could I? Absolutely. If it says find the remainder, that's a division problem. But I'd like you to think about what I just talked about over here. Remember, when I plugged into whatever number comes out here, and I hope it's a 0, but whatever number comes out here is the remainder. If I did the division, the number I plug in is going to be the same number as I get here. Let me show you, because I think some of you don't believe me. Let me show you. Let me use this easier problem. Let's plug in 1. If I plug in 1, I get 1 plus 2 minus 5 minus 6. Now, it's not 0, so I normally would just throw it out. But for purposes of this, what do I get? What's the actual number I get? Negative 8. Okay, what does that tell me? This is not a 0, right? It didn't equal 0, so it's not a 0. But watch what happens if I divide. What happened when I did the division? I got negative 8 as the remainder. So if I plug in 1, whatever it equals is the remainder. I don't have to divide. I can find the remainder by just plugging in. So what am I going to do in this problem? I am not going to divide. It's too much. Too many zeros. It's too big.
Just plug in negative 1.
I'm going to plug in negative 1. All I have to do is plug in negative 1, and the answer comes out to be 18. What's the remainder? 18. It's that easy.
Wait, how'd you get negative 1? Oh, okay.
I am dividing by x plus 1. So I plug in the same number I would divide by. If I were doing the division, I plug in the number that I would put in the box.
I just have a question about that. Is it negative 2 because the 3, like, you're more, like, subtracting it the other way? Like, negative 5? Like, is it 3 minus negative 5?
Well, I'm adding these two together.
Oh,
These are additions.
okay.
I drop the one straight down, and I multiply and add,
Okay.
and multiply and add. So since one's positive and one's negative, it is a subtraction, I guess, but I'm adding those two together. Okay. All right, so that one's done. Okay. Number 2. Oh, we've already done a couple of these. Find the zeros. All right, so here's the problem. First thing, your beady little eyes look at it and say, oh, I don't think it's going to group, right? You see a 17 to 15, that's not good, right, for grouping. So, okay, factors of 15, what are those? 1, 3, 5, 15 over 1. So I don't know, pick one, see if you can find something that works. Somebody already tried 3 and it works?
Oh, no.
3 might work. 1 works, I can see 1 works. Can you see that 1 works? You get 1 plus 1 plus 15 and then minus 17. So 1 works, so I'm gonna go ahead and divide it out. 3 might work also, I'm just too lazy to try it. Here's that 0. That means my remainder is 0. That means I have found a factor. What's left? I went ahead and divided it out. What's left? X squared plus 2x minus 15. Which factors as? Plus 5 minus 3, so 3 was a root, right? Your zeros are negative 5 and 3. And 1. Don't forget about the 1 you guessed. That's one of your answers. How many answers should this problem have, people? 3. Don't write just these 2 down. You want to get all 3 of them. Okay, now, number 3 is a little bit different. If you've been working on the homework and found something like this, you haven't had a chance to look at that homework yet. This is backwards. So look at these problems we've been doing. I've been giving you the equation, and you've been figuring out what the roots are, right? What the zeros are. Well, now you're given the zeros, and you're going to work it backwards and come up with the equation. Okay? Now, I don't think that's too much for you. I think you can handle that. Think about working this problem backwards. Where did those come from? Those 2 numbers right there. They came from these factors. So it's not really a stretch to say, okay, where did the x equals 1 come from? Some factor that was x minus 1. And similarly, this hasn't happened to us, but somehow we got a root of 3i, so that factor must have been x minus 3i. Now, there's one more thing I have to add to this, though. A piece of information you need. It didn't happen here, but if we were going to have a problem that had i's in the answer, think about it for a second. Under what circumstance would we have guessed 1, it worked, divided it out, but then we didn't end up with negative 5 and 3, we ended up with some crazy answers? What would cause that to happen? If it didn't factor. So if we ended up, instead of having that nice little thing, if we ended up with something like x squared minus 3x plus 5, it doesn't factor. So then you would do what? Use the quadratic formula. And you can still find your answers. That's not a problem. But when you find, let me just do this one. It'd be negative b plus or minus the square root of b squared minus 4ac over 2a. So this happens to us. We are not at all fearful of it. We get these answers. Great. Have i's in them, right? Now, have you ever done a problem in your whole life where you got just one of those with an I?
No.
You can't. Every time you get an I as your answer, an imaginary number, it's a plus or minus situation. Think about it every time. So, if 3i was one of the answers, so was negative 3i. Now, the problem didn't say that. You just need to know it because you're a smart person. Complex roots always come with their conjugate. So this one, if I had done the quadratic formula, would be 0 plus 3i, and then this one is the 0 minus 3i. They come as conjugates, always. So if you have a problem and somebody says 2 plus 3i is a root, you will say immediately, so is 2 minus 3i. They always come together. So, if I have a factor of x minus 3i, I have a factor of x plus 3i. Alright, now you gotta FOIL it out, because remember, your goal is to come up with an equation that looks like this. So we'll start foiling, and I would recommend when you have this conjugate situation, start with those, because the beauty of conjugates is stuff will cancel out. So if I FOIL, I get x squared plus 3ix minus 3ix minus 9i squared. Now there's our I squared, which is -1 times -9. These cancel. I have x squared plus 9. Would you agree with that? Don't forget, you still have to multiply by the x minus 1. So we have x cubed, I'll put the descending order, minus x squared plus 9x minus 9. Now, it says it's an equation, so go ahead and stick an equals 0 on the end. Or an equals y. I don't care what you set it equal to, but it's got to be an equation, so set it equal to something. Got it? Not a big deal, just backwards of what we've been doing. All right, number 4. Write an equation for this graph. Well, this is kind of the same thing. Because in the last problem, it said x equals. Do we know what x equals in this problem if you look at the graph? Yeah, the zeros, right? So basically we're saying x is -2 and 1 and 3. So what are the factors going to be? Those are the zeros of the problem. So what are the factors going to be? X plus 2, x plus 1, minus 1, x minus 3, and what?
Is that x?
2.
No, that's a 3.
Yeah, it's a 3.
3 squared. But it would be squared.
Okay, so here's the structure, here's the framework, here are the factors, but Brenton has noticed that needs to be squared. How does Brenton know that one is squared? There's a bounce off there, right? And if there's a bounce off, it means it is squared. Any more bouncing going on there?
No.
No. So are you satisfied that that's the right answer?
No. It needs to be negative.
It needs to be negative. Why does it need to be negative? Look at your picture. It's starting down and ending down. Nothing starts down and ends down unless you put a negative in front of it. Now, do I know what negative it is? I'm just going to put a negative there. Do I know if it's -2 or -8 or -12? No. There's no way of knowing. I want you to listen to this now, because you guys, you're smart enough. You can get this. The coefficient in front of the function multiplies the height, right? Look at my graph. Do I have any horizontal or any vertical scale set at all? Is there any verticalness to this picture at all? So I have no idea how high it goes or how low it goes. So I have no way of figuring out what it's been multiplied by. I just know it's a negative. Now, had I said on the graph, okay, rest it there. Had I said, okay, this point right up here on the y-axis is the point 0, 10. Now, you would be able to tell me what number this is out here. Now you would be able to tell me, you'd be able to figure out n, because you put in 0 for all of the x's and 10 for y, just like you did with your parabolas to find that coefficient. Remember you had that extra point? You did it on your quiz. You had that extra point, you plugged it in. Here I would have an extra point, I could plug it in and work it out and find out what that number is. We can't do that. Just put a negative out here and you're finished. Okay? In the homework and on the test and quizzes, I will specifically say do not multiply out. This would be a do not multiply out. I don't want you multiplying all that out. And finally, number 6, it's the last one on this quiz anyway. The length of a picture is 5 more than the width. Stop right there. I have a picture, I'm assuming is a rectangle since we're talking about length and width. And it says the length is 5 feet more than the width. So what do I do with that? X and x plus 5. The area of the picture is 66. Area, rectangle. So x times x plus 5 equals 66. What do you do with that kind of equation? Distribute.
Oh. Subtract 66. Yeah.
Subtract 66. In other words, get it set equal to 0. And then either factor it if it factors, and you can see that, or use your quadratic formula. So it actually does factor. If you can see that, great. If not, then use the quadratic formula. So my answers are negative 11 and 6.
But it can't be a negative.
It can't be a negative. That's what we call an extraneous root, right? Can't be negative 11. So therefore, the width is 6 and the length is 11. Now I know we did these problems on different days, so it's not, you're not even thinking about this, but the problem above it, the tennis ball problem, we ended up doing negative b over 2a on that problem, if you recall. We didn't do that on this one. Anybody know what the difference is? How do I know whether I'm solving it or if I have to do negative b over 2a? How do I know?
For to do that, you need to know the ALS, right?
Well, okay. So the purpose of doing negative b over 2a is to find the vertex. And what is the vertex of a parabola? It's either the maximum or the minimum. So if the problem says something about maximum or minimum, then I'm going to do negative b over 2a. But does this problem say anything about maximum or minimum? No, this problem straight up says the area is 66. Tell me how to make that happen. So you make that happen by building a 6 by 11. Right? That's the difference. Maximum or minimum, that's your trigger. Okay, I need vertex. All right. Well, guess what? There's more. Look at the next page. Now, before you say, oh no, remember, we have a quiz. What are we working through right now? Quizzes that I gave in the past. Okay, so do you think maybe your quiz is going to be similar to this? Yes. So here we go. Find the zeros. All right, we've done about 15 of these already today. Take a look at it carefully. What do you notice? It groups. Notice the directions don't say you have to group. So if you want to group, fine. If you don't want to group, fine. I want to group. So I'm grouping. Now, if I choose to group, then this has to happen. If that doesn't happen, then you're not going to group it. You're going to do a different technique. And what would be your other technique? Yes. And hope to find 0, right? Okay, here, what have we got? We got a common factor, x plus 4, and then we got x squared minus 4. And x squared minus 4 factors as plus 2 minus 2. So x is negative 4, negative 2, or 2. And it says find the zeros, we're done. Done, done, done. Number 2, sketch. All right, we know how to do this. This should not perplex us. How do we sketch? Plot the point, so we'll put one on at negative 2, and one at 3, and one at 1. Now, what is the degree of this guy? Pay attention to that, because that's going to tell you how you start connecting them. The degree is 4, so we know 4s start up and end up. So it's starting up here. Now, what's it going to do when it hits that point? Just keep on going. Comes up to this one. What's it going to do when it hits that one? Keeps on going. What's it going to do when it hits that one? Bounce back up, and there we go. Now, I have one issue. Yes?
Can you draw a meander?
Yes, but first I have to finish this problem, because I'm not quite done with it, because I threw in a little tricky thing. Label all the intercepts. Now, have I labeled my X-intercepts? Yes. I need those to graph, so I always label those. This problem says label all the intercepts, which means you not only have to label the X-intercepts, which you're always going to do, those are going to be automatic, you also have to label the Y-intercept, because that's what the problem tells you to do. Now, how do we find a Y-intercept? What? Yes, kids. Without doing anything, what can you tell me about this point right here? This point, without doing anything, you can tell me x has to be 0. So, oh, I didn't write my equation down. If x has to be 0, then I am just going to plug in 0 for all of the x's. So every x in the equation is going to be a 0, and that's going to give me negative 18. So my y-intercept, if I did my arithmetic right, is negative 18. So the reality is this guy goes down a whole lot farther than I drew it. I don't care. You label it, we're good. Okay? Now, Brooke has said, what happens when you have a 0 that's cubed? Let's look at an example of that. So this obviously isn't on the quiz, but let's say we had this. Let's say we have this guy. Okay? So here we go. We're going to have a 0 at negative 2 and a 0 at 1. What's the degree of the polynomial? This is an extra problem, not on the quiz. What's the degree of the polynomial? 5. So normally it would start down and end up. But I stuck a negative out there, which means it's going to start up and end down. So that guy right there came from a cubed factor, right? So as this comes down, it's going to curve its way through that point. And then it's going to come down, I don't know, down somewhere, and come back up, and what's it going to do when it hits this one? Bounce off. So that would be an example of that. Rather than just going straight through the point, it meanders through, like an S. Okay? All right. So, I think I see you tomorrow. So tomorrow we'll take our quiz and pick up from there before review. Yep. Tomorrow's a hug day. Yep. All right. Have a great day. I don't know. Just stay here right now, all right?
Follow the directions. Don't forget, Danielle's question of the week in the library for.
Did you turn that? Was that turned on?
You didn't have to. Because